day 2, completing the square. Let's scooch this up a little bit. So today we're going to solve the equations by completing the square. At the end of last time we met, you were turning these into perfect square trinomials, which is the first step of completing the square anyway. So check out this first example. X squared plus 10x minus 3 equals 0. Now before we solve this by factoring, something like this, but there are no factors of 3 that add up to 10. So this is unfactorable. Completing the square will work for anything, whether it's factorable or not. Like number 2, we can factor, which is a little bit faster, but we're going to solve it by completing the square, just to show you that it can be done. So here's what you're going to do first. You're going to want to get the x squareds and the x's to be the only thing on that side of the equation. So we're going to move this negative 3 to the other side of the equation by doing the opposite, so plus 3. So here's our new equation. X squared plus 10x equals 3. Now, I'm going to leave a little bit of space here, which seems obnoxious, but we are going to add something to both sides of this equation in order to make it a perfect square trinomial. Now remember, if you add something to one side of the equation, you have to also add it to the other side. Okay? Now this is going to look really confusing at first, but once you do it a few times, it won't be too bad. So we have x squared plus 10x plus something, we don't know what that is yet, we'll figure that out, equals 3 plus our mystery number. So to turn this into a perfect square trinomial, remember, you take this middle term, we did this right at the end, you cut it in half, so it'd be 10 divided by 2, and then you're going to square it. So 10 divided by 2 is 5, but then when you square it, it would be 25. So we're just going to add 25 to this side of the equal sign. But to keep that equation balanced, we'd have to also add 25 to the other side. Now again, you might be thinking, why did we just do that? Oh, well, stick around, buckaroo. Because now the left side of this can be factored. X squared plus 10x plus 25, that's a perfect square trinomial. It would be x plus 5 squared. X plus 5 squared. Great, so the whole left side is x plus 5 squared. The right side, we have 3 plus 25, which is 28. And now this is something that we were solving the other day. Remember, we get rid of the square by doing the opposite, the square root. So we are going to square root both sides of the equal sign here. Now 28 is not a perfect square, but it does have a perfect square in it. 28 is 4 times 7. Right? And the square root of 4 is 2, so it would be 2 root 7. But you're like, oh, Mr. Plant, don't forget, Mr. Plant, that square roots are positive and negative. So we're going to write that as plus or minus 2 root 7. That's the right side of the equation. The left side, we still have the square root and the square cancel each other out, so we just have x plus 5 equals plus or minus 2 root 7. There's one more step, and then we're done. We got to get rid of that plus 5. How do we do that? By subtracting 5 from both sides. Remember, you write the radical stuff at the end. So our final answer will be x equals negative 5 plus or minus 2 root 7. Remember, that is telling us two different solutions there. That's saying negative 5 plus 2 root 7 and negative 5 minus 2 root 7. If you substitute either of those in the original equation, they both work. So this is how you're going to write it. You could write it as two separate things though if you'd like, but this is a little simpler and a little more common. So look at number 2. Again, factorable, but we're not going to solve it with factoring. We're going to get our x's to be the only thing on this side. So we have to move negative 20 to the other side by adding 20. And 0 plus 20 is 20. No big deal. So we'll have x squared plus 8x. And remember, we're going to leave a little bit of space because this is where we're going to complete our square. Equals, we have 20 over here, plus, remember, whatever we use to complete the square here, we're going to have to add to that side as well. So let's figure out what that is. We take our b, which in this case is 8, and remember we divide it by 2, and then we're going to square it. So 8 divided by 2 is 4, and 4 squared is 16, plus 16 over here, plus 16 over here. We got to keep it balanced. If you change one side, you got to change the other side. So the left side, this x squared plus 8x plus 16 would factor into x plus 4 squared. X plus 4 squared equals 20 plus 16 is 36. I'll make sure that I always pick the squeakiest markers for you guys, okay? How do we get rid of this square? Oh, Mr. Plant, we square root it. Come on now, Mr. Plant. Come on. So this cancels out the square, so we just have x plus 4. And 36 is a perfect square. It's 6, right? But remember, were you going to forget? I didn't think so. Positive or negative 6. Cool. And then we just got to get rid of plus 4 by doing what? Minus 4. Now there are no radicals here. So initially we're going to have negative 4 plus or minus 6. But since we have no radicals, let's just do that and figure out what the final answers are. So negative 4 plus 6, negative 4 plus 6 is positive 2. And negative 4 minus 6 would be negative 10. Again, if you substitute those into the original equation, they both work. Now look at that original equation. X plus 8x minus 20 equals 0. If you were to factor that, that would factor out to x plus 10 times x minus 2 equals 0. And then you would solve it. X plus 10, x equals negative 10. X minus 2, x equals positive 2. To me, so much simpler to do it this way. But why would we ever learn this? Because again, we can't factor everything. Not everything is factorable. So we gotta have a backup just in case.